In the previous video, I built the Arduino Pro Mini LED matrix display, which I used to make the Pong video. And in this video, I'm going to discuss how these LED matrices work internally. So anytime you work with one of these LED matrices, you're going to get a data sheet. And within that data sheet, there will be an image that looks something like this. In this case, this would be a 4x4 LED matrix. In the Shield, I actually use a 5x7, but conceptually it's the same. In this image, each one of these LEDs in the matrix is represented by an LED image. So this triangular thing with the arrows coming off. And each one of these pins is represented by one of these pins. And basically, there will also be numbers on the side corresponding to the row or column which each pin controls and corresponding to which pin on the integrated chip it's actually talking about. So in order to understand how to work with one of these, we need to know a little bit about how LEDs work. And an LED is basically a one-way valve for current. In other words, it only allows current to flow in the direction of this arrow part of the diode. And to demonstrate that, I have just a regular LED and a coin cell battery. And I've labeled the negative side and the positive side of the battery and the negative and the positive side of the LED. So if we connect it backward, nothing's happening because current is trying to flow in the wrong direction and it won't allow it. If we connect them both to the positive side, nothing happens, or the negative side actually in this case, nothing happens because there's no current flowing. And the same is true of the positive side. But if we connect the negative side to the negative side of the LED, then we see that it turns on because current is allowed to flow in that direction. And this is really important when we're trying to control which LEDs turn on. So basically, in this matrix, if we wanted all of the LEDs to turn on, we would set this side to positive and all of the pins on this side to negative. And that would allow current to flow through all of the LEDs to the corresponding pins. However, if we only wanted, for example, this row to turn on, we would set all of these pins to negative and this pin only to positive, while leaving these all either disconnected or negative. That would allow the current to flow from this positive through each one of these LEDs to the negative side. So then, for example, if you wanted the diagonal to be illuminated, what you would do is by controlling each one of these, so for example, only this LED, we would connect this part to positive, this part to negative, and connect each one of these to positive and this to negative. So plus, minus, plus, 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 minus, minus, minus. And that would cause only this LED to be illuminated. Then we would go ahead and we would set this to negative, this to positive, this to positive, this to negative, and then only this LED would be illuminated. And we'd continue on setting this to negative, this to positive, this to positive, this to negative, to illuminate this, and so on, until the entire diagonal had been illuminated with one flashing light each time. Now, if this happens fast enough, then your eye doesn't perceive it as blinking, but rather perceives it as on, because Just like the settings on a camera, if you take a very slow image of a car on a highway, then you can see the lines of the headlights. Similarly, your brain can't interpret the light flashing that long, so you have persistence, what's called persistence of vision, and you only see it as on. And by doing that, we can create any combination of on or off LEDs in this LED matrix display. So there's one more thing that you actually need to know when working with these in your Arduino or any other microcontroller, and that is that LEDs have a maximum operating voltage and current. And if you exceed that, then the LED will explode, which is really bad, or it will burn out. It will die in some way. So in order to prevent that, frequently you'll see an LED in line with a resistor. So your LED will have either a resistor before or a resistor after. It doesn't matter. And that makes it so that the voltage drop across the LED is the correct amount for it to operate in a happy state. So that's why in this LED matrix display, I have the 5 resistors on the back. So that could be represented like this. And that allows each one of these LEDs to operate at the correct voltage with the correct current. So I hope that explains why this whole thing works the way it does and a little bit of how you would program it in your microcontroller.